Welcome back, everyone, for the sixth edition of Waste to Energy Virtual Conference. After that highlight panel discussion, we are moving towards the technical presentation, and we have Dr. Asit Das, who's the head of research and development refining for Reliance Industries Limited. And I hand over the mic to Dr. Das to come on stage and start the presentation.
Yeah, good afternoon. I must thank at the outset Gasification India organizers for giving me this opportunity to share some of our thoughts, views, and technologies that Reliance is working upon to convert waste to value. And many of them are basically waste to energy. So I will be speaking to you about RIL's breakthrough technologies, waste to value. Basically, this is a disclaimer. The statements opinion are on my individual capacity, and Reliance has nothing to do with it. As you know, Reliance is a Fortune 500 company. It's a #1 company in India, and 10 years back, it was mostly focused on refining and petchem. But today, as you can see on the right side, the EBIT is about 13.6 billion in last year, and of that 65 is refining at petchem and 35 is consumer centric businesses, basically covering Jio platform, Reliance Digital, and also Reliance Retail. So Reliance is diversified into multiple areas, and this will further go on. This afternoon, I would be focusing on three breakthrough technologies that Reliance has developed, and these are at different stages of development. In short period, we'll be going to demonstrating these technologies. So this technology is primarily focused on India, although many other countries can also adopt. Basically, it is for highest Indian coal and biomass. This is integrated with CO2 capture. Then we have a very breakthrough technology on this RCAT HTL, hydrothermal liquefaction. It's basically for all kinds of biomass, but more focused on wet biomass. And we also have a process for waste plastic to virgin plastic, chemical recycling. We expect it to get about 55 to 60% circularity. When we talk of energy sector, specific to India-centric innovation, we have to keep it in mind that there are 4 circles which have overlap: the availability, affordability, sustainability, and productivity. So the technology that we intend to develop encompass all these circles. So far, India was in sort of feedstock. We are importing a lot of oil and gas. It's on a heavy burden on economy. Fortunately, the world is moving towards circular economy, and as you know, India is a agro-based country. A lot of agro biomass is available. India also has highest Indian coal. There are lots of municipal solid waste, waste plastic, etc. If we can convert this waste material into chemicals and energy, this would bring a lot of circularity and greenness to our energy sector. So that's the core thing that I am going to present to you, that how our technology development would lead towards this. And on affordability, there are a lot of rural development possible if we can convert the biomass into bioethanol, methanol, CNG, hydrogen. So all these are green products which are possible from biomass. Integrated CO2 with highest Indian coal also can lead to sustainable solutions for energy. So these are the core topics that I'm going to cover. Right. So agro biomass, high as Indian coal. Let's see how Reliance Catalytic Gasification integrated CO2 capture helps. Last year, we presented you this catalytic gasification technology. We have advanced it further. We have incorporated biomass in a big way for producing syngas, green hydrogen, and also utilizing that to produce biomethanol and bioethanol. So, as you know, catalytic gasification is a breakthrough technology. It has a solid catalyst circulating in two fluidized bed. It has a gasification without any oxygen, so it's steam gasification. On the right side, you will see that, and on the left side, the catalyst circulates to the another vessel, which is the combustor. It operates about 750 degree. So the temperature is much less. It's a low temperature catalytic gasification, which actually allows no oxygen requirement here, because basically the air is burning in the combustor, and there is no oxygen or air given in the gasifier. So what are the benefits? Low temperature, it works like 3 years, 4 years on stream factor you can have, which no gasification technology can provide. It is much similar to FCC platform in refineries, having two vessels. So there are lots of advantages. Like in biomass, you don't get any tar, even if you operate less than 700 degree. So very high carbon conversions. The other thing is it also not only catalyzes the carbon steam gasification, but it also catalyzes the water gas shift reaction. So therefore the syngas is hydrogen rich. It requires very little shift of the CO at the latter stage. So these are the basic benefits. We have presented this case to Niti Aayog. This can handle highest Indian coal in a very efficient manner. So Niti Aayog has shown keen interest for taking part in the demonstration and commercialization. And we are going ahead for demonstrating this technology at suitable scale so that we can move forward for commercialization to convert the biomass into green hydrogen and lots of other syngas based products. We also have a CO2 capture technology. As you know, this is again a solid sorbent based. It is a low temperature process, and unlike the amine based process, the advantage here is it has a 40% lower capex, 70% lower capex, and 40% lower opex. So overall, we get about 60-70% reduction in the cost. It's less than $20 per ton of CO2 capture, which is very unique. So this can be integrated to the gasification. Let's look at the economics. If we adopt catalytic gasification and apply it for highest Indian coal, it is possible to produce SNG at less than $3 gas cost, which is almost like shale gas. You get an advantage about $3 to $4 gas cost reduction on the syngas. That's very significant. How does it happen? You get almost like 15 unit increase in coal gas efficiency. You get, it's a low temperature process. The calorific value of the syngas is roughly about 600-700 kilocal higher than what you get in the thermal high temperature entrained bed processes. And because it is a low temperature, you get a very effective utilization of the heat, and loss of sensible heat is also much less. So both on actually the benefits is even higher when you deal with methanol, because of the advantage of hydrogen to CO ratio on the higher side. We can significantly utilize the CO, hydrogen and CO amicably to produce methanol. You can see here the methanol production from entrained bed normal gasifier is 0.6 ton per ton of heat, highest Indian coal, whereas here we get about 0.9 ton, which is significantly higher. Per ton of feed, we get much higher methanol. And also to that extent, agrobiomass helps. Similar advantages also there. The capex and opex numbers are typically on an average, I would say 50% lower capex and opex with this technology. So if we can convert 250 million ton biomass, we can produce 60 million ton of syn crude or equivalent green methanol or green hydrogen. That's a very significant number, which can go a long way to take care of the energy and fuel requirement of the country. I shall speak to you now about the HTL, Reliance Hydrothermal Liquefaction Technology, which is again a catalytic process, and it's more oriented for wet biomass like MSW, food waste, organic sludge, etc. But it can also handle dry biomass if it is made in slurry form. It's a high pressure, about 150 bar pressure, but moderate temperature and without hydrogen process. No hydrogen is used in this process. So it's a catalytic pyrolysis process in which the slurry form of the feed is used, the biomass is converted into pyrolyzed product. But because of high pressure and near supercritical condition of water, we get very good stable product. Actually, the liquid product has very less quantity of oxygen, so deoxygenation reaction is very high. The yields are much higher, and the biocrude thus produced can be brought to refinery, and we can convert that very easily to a compatible refinery compatible crude with minimum hydrotreatment and desalting possible. So if we can convert 70 million ton bio waste from MSW and food waste, etc., it's possible to get about 20 to 25 million ton of biocrude, depending on the type of bio waste. Now let me show you the biomass to energy. There are varieties of technologies available, and you can get different thermal efficiencies. The first one is for from same agro waste, agro residue, power generation. You get dry biomass to electricity by combustion. You get roughly about 27% thermal efficiency. Then you do 2G ethanol through fermentation route. You get about 34% thermal efficiency. The hydrocatalytic pyrolysis to gasoline, diesel, and kero, you get an efficiency of about 56%. If you do anaerobic digestion, which is used for biogas, just the biogas part gives the thermal efficiency of 48%, but once you produce power out of it, you get roughly only 18 to 20%. Because the carbon conversion in anaerobic digestion is not very good. Now, compared to all these, the ARCAT HTL, you get a biocrude from this process. You get roughly about 66% of thermal efficiency. So, which is much higher compared to any other wet biomass based processes. If you look at the hygiene and clean off gas, wet feed processing, feed flexibility, technology maturity, water recovery, and footprint of CO2 and capex, in all these, ARCAD HTL clearly appears to be a winner. In most of the cases, this is on positive side, and this technology has been evaluated in world arena, and many large companies have shown very deep interest because of the inherent advantages. Now, let's talk about, for biomass, you have several technologies available to produce all kinds of different products. You have biogas anaerobic digestion, then you have 2G bioethanol, then 3G bioethanol. What we are talking 3G is basically catalytic gasification combined with gas fermentation. This is 3G bioethanol we are talking, but it could be even higher G actually, because it is more efficient than 3G, which is based on algae root in terms of the economics. Then the Arcade HTL for biocrude. Here there are some very rough cut ballpark comparisons. I would put it. As you know, the biogas, almost 80% residue is left over. You get about 13-14% biogas. 2G bioethanol, you get main product yield. I am talking about 19 to 20% you get bioethanol. Now you look at 3G bioethanol, you almost get per ton of biomass, you get about 45% as bioethanol in 3G route. And if you take wet MSW based on the dry basis, essentially you get per ton of dry basis feed, you get about 500 kg of biocrude. So you can see that both these technologies, 3G bioethanol through catalytic activation and Arcade HTL, the desired main product yield is significantly higher. And why is it? Because the residue, it's full-fledged conversion. Most of the carbon is getting converted. Unlike the biogas process where you have almost 80% residue, and 2G bioethanol, you have a lot of biomass still left. The lignin part is really not converted. So you get low carbon conversion. Whereas in catalytic activation, you get 100% carbon conversion through either energy or to ethanol. And in biocrude also, you get significantly high, 75% carbon conversion you get. So how do the capex number look like? Obviously, when you look for advanced technology, the capex for 3G bioethanol would be higher, but you get a very good return, actually much better than 2G bioethanol. This is self-sustainable at 500 ton per day capacity plant with a very good payback of around 4. I won't say very good, but it is acceptable payback of 4.5 years. And if you look at Arcade HTL, it produces biocrude, 75% carbon conversion, and the capex number looks pretty similar to 2G bioethanol, and you get a biocrude which is 50%, and you get very good payback. But this is not on one-to-one basis comparison, but the comparison for one-to-one basis also you get around 4 years payback. If you take the same paddy straw, Arcade HTL, you get about 3.8 to 4 years payback. So let's talk about Reliance, sorry, waste plastic to virgin plastic, circular economy. Plastic, waste plastic is a problem, and the current technologies of thermal pyrolysis are having also problem. That is why the waste plastic issue is not resolved. Thermal pyrolysis technologies are already being practiced in small scale for last several years, but the technology is not trouble free. Thermal pyrolysis have got problem of pre-processing of feedstock is required, segregation of feed is needed, issues with processing of as received plastic. It yields to high viscosity and hot slurry pumping also sometimes is required. Inside the reactor, because of low depolymerization reactions kinetics, it ends up in sticky char and tar formation inside reactor, which leads to heat transfer problem because these are rotary reactors in most cases. So the heat transfer gets disturbed, and after some time the reactor requires cleaning, etc. There are thermal cracking related products, non-catalytic. So you have more char yield and more gas yield. And the products which are produced are no good. It yields to lower liquid yield, high coke and char and residues. It also have poor liquid stability. Liquid products are not stable. Oxidation stability is not good. So these are some of the challenges in today's technologies. Uh, we are talking here the Reliance catalytic pyrolysis technology, which is again based on rotary reactor. But here we add catalyst, and if if in a site there are a number of catalytic pyrolysis reactor, we can design up to 20, 25, even up to 50 ton per day of plants based on these rotary reactors. But if there are a number of plants, it's possible to regenerate the catalyst. This catalyst is very cheap. It can be regenerated also without trouble and recycled back if in a site the catalyst requirement is high. What do you get compared to thermal pyrolysis? You get about 100 degree, 60 to 100 degree lower temperature. You get about minimum 10% improvement in the yield. Liquid yield as high as 80% of the waste plastic. You don't need to segregate the plastic. It can be fed even with soil, etc. It can be fed because it has a very good way of removing the char without disturbing the reactor. It runs in negative pressure, unlike many thermal pyrolyzers which run in positive pressure, and it is unsafe to run positive pressure because of hydrocarbon leak to atmosphere. This reactor operates in negative pressure, and in a very good balance you get out the gas, but without really ingressing oxygen inside it. The gaskets are designed in that manner. So it operates over 100 degree lower temperature, and you get about 80% liquid yield. Because it is catalytic, the product looks like FCC product, which is common to refinery. It's much more stable than thermal products, and it can be brought back to refinery and connected with refinery FCC streams, coker streams for further upgradation. But most importantly, we plan to again produce chemicals out of these nut fuels. And we have processed all kinds of segregated, unsegregated, mixed plastic, multi-layer plastics, all kinds of waste plastic have been processed in this route. This is a patented technology, so you get differentiated liquid yield is much higher, and it looks like a catalytically cracked product, which is having higher olefins but much less diolefins, much better stability compared to all that you get from thermal products. Now the products, the stable product catalytically produced from waste plastic, we plan to bring it to refinery and process in this breakthrough oil to chemical technology which Reliance has developed, and it is under implementation. We are designing a bigger scale unit inside the refinery. This is a patented multi-zone cat cracking technology in which multiple feed can be processed simultaneously in the same single riser in multiple zone. What you get out of it, you look at the yields that this process gives. Out of crude, directly you can process crude or refinery streams, or the crude produced from biomass, or the crude produced from waste plastic. You can inject it in one of the zone, and the naphtha produced are recycled back in different zone. So thereby what you finally get is no fuel practically. You get ethylene about 24-25% of your feed. You get propylene about 30 to 35%, and you get BTX about 15%, practically very little fuel, or I would say no fuel. You get aromatics, you get olefins, ethylene and propylene, and this actually can ethylene and produce, as you know, again we can produce plastic out of it. So overall what we have seen is you get roughly waste plastic to virgin plastic. You can essentially get 55% circularity by combining the Reliance catalytic pyrolysis along with multi-zone cat cracking. So in summary, I would say that these are some of the brand new technologies, and Reliance is active on commercializing them in different demo scale and next commercialization scale. So thank you very much.
Thank you. Thank you, Dr. Das, for the wonderful presentation. I would request you to stop sharing the screen. Thank you so much. And moving on, we have Mr. Amit Kulshrestha, who's the General Manager, Waste to Energy from NTPC Limited. I would request him to please turn on his video and audio so that we can have a next presentation before we move to question and answers.
Good afternoon. I am Amit Kulshrestha. I am General Manager and Head of Waste to Energy Department in NTPC. So the waste to energy in NTPC means the waste not only limited to the municipal solid waste but also the agro residue. And the energy is not only electricity but any other form of energy also. So we are responsible for converting this agro residue also into some useful energy forms, or in addition to this, we are also exploring the projects for converting municipal solid waste into energy. So the today's topic is the technology and environmental aspects. So considering the environmental aspects and the technologies have to be finalized, have to be selected. So what are the technologies which are useful with reference to the environmental performance of the plants, that we will also try to understand. So now first the agro residue. Agro residue, according to various sources, is between 500 to 600 million tons per annum, which is produced in our country, and around 140 to 160 million tons is surplus. So the 70 million ton out of that is rice straw based, and around 70 million ton is other agro residue. So rice straw, because it has high silica content, it is a major cause of concern as it is not used as animal fodder. And also in Punjab and Haryana, because the sowing time for the next crop is just after 20 to 25 days after the harvesting of the rice. So they don't get enough time to take out all this rice stubble, and they burn it into their farms. So it is a major cause of concern because of the environmental reasons. So you all know that this North India suffers from heavy smog during those periods, and it is a major cause of worry because of the health issues. According to some studies, you might be knowing that this causes around $30 billion of loss every year because only of the health issues. So it is a major issue which we must address. And for that, NTPC has started some initiative that I will brief you. The Punjab and Haryana figures are this: around 25 million ton of rice straw is generated there, and it has good energy potential. So what we are doing is we are exploring to use it in power plants along with coal, and how we can replace the coal with this kind of fuel. That is the major this strategy for us. So we are doing doing it in two ways. First is we are converting it into the biomass pellets, and then we are procuring those biomass pellets and mixing it along with coal to co-fire into our existing power plants. So say up to 10% of the coal can be replaced through this method. Another way is to torrefy this material and convert it into charcoal-like material, make the pellets, and then fire along with coal or replace the coal. So in that case, you can even replace more coal. Maybe 15-20% replacement is also possible. So these are the two ways we are going to utilize these materials in our power plants. So some policy after this NTPC experimented these methods of co-firing in our power plants at NTPC Dadri in 2017. Ministry of Power and other agencies came up with relevant policies to enable these kind of co-firing in all the power plants of the country. So in 2017 November, MOP brought a policy that up to 10% of co-firing should be done in all the power plants in the country. We conducted the test firing in September. After 2 months of that, the ministry came up with this policy. So this was basically subsequent to the initiative by NTPC and the confidence which ministry got because of the NTPC's experiment. And then 2019 CRC regulation also enabled the passing on of these costs to consumers. So whatever additional expenses the generating companies will incur, they will be reimbursed in the form of additional tariffs. REC benefits have also been assigned in February 2020. So now this biomass power will be counted as non-solar REC, and the non-solar REC benefits will be given to the buyers of this power. So this is the actions by NTPC what we have done till now. We had ordered 14,500 tons of rice straw last year, out of which 9,400 tons we have already burnt at Dadri, and it has been able to save around 4,700 acres of farm fires by already firing this much of material at Dadri. Further, we have also issued purchase orders for 280 tons per day quantity, which is around 1 lakh tons per year in April. And these are against the long-term tenders, 4 years tenders. So total 4 lakh ton quantity is there. And the supply is going to start from January. Then NITs were issued for 17 plants of NTPC to procure this kind of material, biomass pellets, agro residue pellets, the normal pellets as well as the torrefied pellets. And the total quantity is 20 million metric ton. And this contract is also for 4 years. So every year the quantity is around 5 million metric ton. Bid opening date has been extended. So it is not 30th. It is by mistake I have written this. I think the date is 23rd. So 23rd of December this month. Then short-term tenders also we have issued for all the 17 plants, out of which for 4 plants we have already issued the purchase orders. So this is the general status what we have been doing for this kind of material to utilize this agro residue in our NTPC power plants. Out of these 4 plants which I have mentioned, Moda, Unchahar, Kudgi, Simhadri, Moda and Sholapur, and even Sholapur is also there. Yeah, so Sholapur I have written. So Moda and Sholapur, they have also started firing it. Unchahar has also started firing it. So this was all about the agro waste utilization. Now let us come to the waste to energy, principally the municipal solid waste to energy. So for municipal solid waste, NTPC is installing 2 plants based on the incineration based technology using Rankine cycle converting to power. The one plant is at Kavas, and the another plant is part of a bigger circular economy village at EDMC. So Kavas is basically we already have a power station there, gas-based power station, which is very near to Surat city. So that plant will utilize the municipal solid waste generated from Surat city. The only RDF component will be given to us through municipality. So the waste supply agreement is yet to be signed there, and the bids have been opened. We hope that it will be concluded very soon. Similarly, for EDMC power block, the same kind of technology using a plant. There also the bids have been opened, and they are under technical evaluation. So plant is based on 600 tons of dry combustible waste, and it will also generate electricity. So maybe 12 to 13 megawatt of electricity will be generated. Other than this, this total EDMC complex is based on 2,000 tons of total waste, out of which 1,200 tons of waste will be used for biomethanization. 600, I have told you already that it will be used for power generation, electricity generation, and then 200 TPD will be used for C&D recycling facilities by EDMC. So in addition to this, we already have a plant at Varanasi which is converting 24 tons of waste into gas. And then that gas is used, the syngas is used for generation of electricity. So then another 600 TPD plant is going to be installed there, which will be converting the combustible fraction of the municipal solid waste into torrefied coal. That will be charcoal-like substance, and then that coal will be utilized along with natural coal in our existing power plants, or it may be sold locally. On similar technologies, or maybe with some other technologies, we are going to install Indore, Bhopal, and Hubli Dharwad plants also. So this is the brief of some of the plants which we are bringing up on for waste to energy. Regarding these technologies, you might be aware that the gasification process as well as the torrefaction process, they occur in the absence of oxygen or with very little oxygen. Like gasification requires lesser quantities of oxygen. So the dioxin and furan generation is less, it is avoided. So these technologies are much safer from the point of view of environment. So whereas this incineration based technology, where the combustion happens in the with excess oxygen, there are chances of forming dioxin and furans wherever the temperature ranges are conducive to that. So we need a very elaborate gas cleaning system there. Hydrochloric acid fumes and other fumes which are toxic, they are also generated during the process, and they all need to be separated or captured before the gases are emitted into atmosphere. So this is the typical flow diagram of a waste to energy plant based on incineration based technology and using Rankine cycle for power generation. So you can see that the waste is dumped into a big bunker, and then this bunker is kept under partial vacuum, and then the waste is fed into a great furnace where the waste is combusted and the hot gases are emitted. Then the heat from those hot gases is captured through heat exchanger surfaces, and the steam is generated. Then the exit gases, they undergo massive treatment for capture of toxic substances like dioxin furans or acid fumes or the SOx, NOx, etc. So the clean gases are then discharged into the atmosphere. Although the gas cleaning system is normally very elaborate, but the efficiency depends upon the operational practices of the developer. So we may find that there are a lot of emissions in some of the plants in our country where the emissions are more and the local population is suffering. So that is one of the issue, because the local resistance is there in our country. The plant is also not maintained very properly in some of the places. So the local population is opposed to such kind of plants because of the filthy surroundings and obnoxious smell. So, but this all is basically the operational issues, how well the plant is operated. Otherwise, design-wise, the emissions can be controlled very nicely. And you can see some of the European plants which even exist in city surroundings, even in the center of the city. So these plants are considered very clean there, but still there are some public opposition in some of the countries like US. They have installed very few plants of such kind. So the other methods which I have already told you, the more environment friendly methods are gasification and torrefaction and other ways, the biomethanization also. So where the biomethane generated is used for converting into bio-CNG and then used for transport purposes. And the reject is used for this as a fertilizer. So there are various ways of converting waste into energy or electricity or any other form of energy, but there are environmental impacts of all that we have to keep in mind while implementing such solutions. So this is a typical block diagram of a circular economy village which we are going to propose for East Delhi Municipal Corporation. The project is being implemented by NTPC. Here these flows which I am depicting is not for EDMC, but these are some typical flows. There the flow is, the total municipal solid waste is 2,000 tons, but these flows which we have indicated are just typical flows. So don't go by these figures, but the general scheme you can see. The municipal solid waste is first separated into biodegradable part and non-biodegradable part. So biodegradable part goes to the biomethane plant, and the other part after some other process is separated into C&D fraction as well as the combustible fraction. C&D fraction is going to a C&D processing plant where it is again recycled as a this construction material, like the concrete and sand. All these things are derived from that. So this C&D part is processed separately, and the combustible fraction is fed into a incineration plant where this waste is incinerated to get the energy out of it and then converted into electricity. As you all know, that electricity generation process emits a lot of heat also. So you have to reject a lot of heat also. If 1/3 of the energy you are converting into electricity, 2/3 of that you are wasting as rejecting from the system, because the thermal cycle dictates that you need to reject some heat to convert it into electricity, or to this rejection of heat, if we can utilize for district heating cooling, then it can be a good option. So we are conceiving this also at East Delhi Municipal Corporation, that the heat rejected will be utilized for generating heating energy or cooling energy for the surroundings. So this is basically a circular economy concept where each and every part of the waste is being utilized. So and goes back into the economy. So it is called a circular economy concept. This is the waste to coal initiative. We have installed a pilot plant at NTPC Dadri, which is right now being tested for its replicability at other places. And the Varanasi plant we are going to install on same principles. This is a pilot. We will add some other things to this and we'll make a elaborate plant there. So because heating, as I have already told you, that it is done in the absence of oxygen, so no dioxin and furan formation is there. High calorie charcoal is generated, and which can be utilized in power plants. Similar plants can be used for distributed application even in villages. So it has a good potential to replicate in our country. Thank you. So this is all about the environmental impact of the plants and the technologies which we are exploring. So any questions?
Thank you, Amitji, for the presentation, letting us know about the initiatives from NTPC. Before we move to Dr. Kasba, we have few questions for you from this is Gurkirat Singh Gilji, Director GRV Real Infra, who's asking what is the pattern of the finalized tenders, knowing the financials is important for making viable proposals.
So regarding the cost of agro waste pellets, so it depends on the tenders, because it is a competitive price which is awarded. So the past awarded prices, I can throw some light that they are less than rupees 2 per 1000 kilocalorie. For example, it is a material with 3000 kilocalories. Then the cost is around 6 rupees or less, delivered at NTPC Dadri. So this is based on the Dadri tender, past tenders, and then those tenders which were for shorter duration. But the cost, we expect that it will come down because of the competition in larger tenders, where the delivery period is also begins after 9 months, where the startups have also opportunity to install their own plants. So this all depends on competition. I am only giving you some past data which may not reflect the future opportunities.
Manager for Eastern Coalfield, he's asking how much waste is used for Kawas every day.
We are planning to use around 600 tons to 700 tons of RDF every day, which will be the dry fraction of the municipal solid waste, dry and combustible fraction of the municipal solid waste. It is basically the RDF part.
Next is from Sunil Dhingraji, who is a senior fellow at TERI. Question is, what is the price of pellets and torrefied pellets NTPC is procuring?
That question I have already answered. I told you that it is less than 2 rupees per 1000 kilocalorie for both the type of pellets.
And there's a follow-up question. What is the comparative emission level with 10% co-firing mode?
Emission levels are the major reason for using this kind of technology. Basically, the pellets have less sulfur, so SOx emissions are quite less. And then this NOx levels are also reduced because the temperature of combustion reduces because of the flame temperature reduction due to high volatile contents. So the SOx NOx reductions, there are apparent advantages, but in addition to that, the major advantage is that you are not burning this in open fields where the lot of particulate matter is generated, and you create a foggy this visibility problem and this respiratory issues. So the pollution is avoided. Then this fuel is basically considered carbon neutral, because whatever carbon we are burning is absorbed into next cycle, in the next crop cycle itself. So there is no net increase in carbon dioxide in the atmosphere. So it is considered renewable and carbon neutral fuel. So you are avoiding also the carbon dioxide in while burning this.
We have a final question. What is the CV of the RDF for the waste to energy plants NTPC is involved with?
The municipalities have promised us the GCV of more than 2500 for the RDF part, for the RDF which they are going to deliver. Where we are making our own RDF, our own processing system will take care that we generate the RDF above 2500 or around 3000 kilocalorie.
That is it. We have covered all the questions.
Thank you.
Thank you so much, Amitji, for joining us.
Thank you.
It was a wonderful presentation.
Thanks.
Moving on, we are still open taking questions for Dr. Asid Das. And now we have Dr. G.N. Kasba, who's a senior advisor at IRADE and former commissioner for Srinagar Municipal Corporation, joined us to share his thoughts and his views, being an expert and the most experienced fellow who has worked on a lot of waste to energy projects in Srinagar Municipal Corporation, still working on multiple projects to make this vision possible. Over to you, Dr. Kasba.
Thank you very much, Akshay. First of all, I must thank you and the Gasification India 220 and for inviting me. And although I'm scheduled to be a panelist tomorrow, but it was decision taken by you that I should also participate in current session. Thank you very much for that. I think it's very important. I have been hearing and learning and handling the problem on municipal solid waste since 2012, and almost for 3 years without break. And what we see the major problems is the attitude of the our citizens towards the municipal solid waste and its disposal. And we would say that with confidence that in 2016 municipal solid waste rules, which are called now the solid waste management rules 2016, 1 year was provided just to prepare for implementation of these rules. But after 2017, these rules had to be enforced. What's most important, we have not, as on date, uh, any guidelines that how to enforce it. We have been at the various municipal corporation at the city level. We have been using our own bylaws, our own rules and regulations of governing city sanitation to implement these rules. But there is no particular guideline or prescription that how to implement these rules, and violation is more of a rule than something we see. For example, the gated accommodations, gated colonies were required to have an in-house system whereby they had various options, either go for a composting or go for biomethanation or whatever is possible, but it has not happened. We have also seen that panchayats under the new system, what municipalities do in cities and towns, panchayats were asked to do the same thing in the rural areas. And we have yet to see the some of the success stories in the country. And I think that would definitely encourage others in the villages to do the same work, to do the same sort of an implementation of the solid waste management rules in the villages. Now, I think the biggest challenge in our country is, which is I have seen across the country, is the segregation. Despite the fact that municipal authorities have provided these two-color bins for biodegradable, non-biodegradable, wet and dry waste, but compliance has been more discouraging. We have not seen. Now, how to improve the compliance? Because any sort of initiative on this on the household front would have an implication whether you go for any sort of the solutions subsequent, even including the waste to energy. And we have been charging user fee from all the households in the Srinagar city. But I was always thinking that if not giving us the segregated waste, it increases the problem, it increases the workload on the labor force, on the transportation. One idea is that those households who show the compliance should not be charged any user charges, should not be charged 100, 200 rupees, which is, or at least 50% concession could be given. Unless until compliance and segregation is incentivized in the country, I think we may not get a headway. It will be another 10 years, 15 years. Maybe by that time things would change. But in immediate future, we can't see anything happening on that account. Honorable Prime Minister led a huge campaign all over the country on the single-use plastic. Again, we may have to find, experts will have to find uh, either the alternatives or the disposable systems, viable and sustainable disposal systems. Indore is doing some work on this. They have the ATM machines for the plastic bottles. But whatever work is being done anywhere in the country needs to be publicized and well documented in the form of documents, in the form of small YouTube documentaries. I think that would be very important. Coming back to what we are listening to the experts is about the waste to energy systems. And we always feel that it is highly it's highly capital intensive. Where from the funds would come for this sort of an approach? Either it has to be public private partnership, then a country level policy on public private partnership shall have to be drawn out by the Ministry of Urban Affairs or the Ministry of Forestry and Environment and Forestry. If some sort of an policy decision is taken that how the private public partnership would work, or how the initial projects, initial 100 or 200 projects, as we have the smart city projects going on this time, I think if I'm right, around 200 cities. These could be waste to energy initiatives could be connected to at least on pilot basis to these smart city projects. That would be very important. And then cost sharing by between the federal government and the states. That also has to be uh, very well documented, and a policy on that has to be uh, enumerated. And what I would suggest that 90-10 ratio, 90% federal government and 10% the state governments would be an initial good headway that would make a good headway on this uh, waste to energy programs. Now, I think it's very important because we were talking about the calorific values. I think I've been listening to these sessions since morning. I think everything revolves around the calorific value of our waste, and per capita is less than a half kg in the country, and elsewhere it is more. And we are that way producing more waste per capita than the China. As for calorific value goes, that varies. That lifestyle and level of uh, prosperity varies from towns and cities, from states. I think a survey, again, I would say connected the survey on the quantification of the waste throughout the country. And if you connect it to the smart city projects, it would be an additional advantage, because we had seen that smart city projects, that spending is not that fast. And also it has been viewed very seriously at the central level, being monitored by the Honorable Prime Minister himself. And spending by majority of the states has not been that encouraging, and people have been looking for the projects and looking for the opportunities where to spend money. But waste to energy would be one of the very good additions, because solid waste management is in crisis in the country. It has to be in focus. Quantification of municipal waste I emphasized. Then another important, I would suggest that we have seen disasters. Now, as for the Srinagar 2014 flood was concerned, we had a huge waste from households and from the godowns, from all sorts of habitations, as Srinagar was around 16 to 20 feet underwater. We had a huge waste. Rather, everything what was at the 16 feet level turned into waste, including the municipal waste. Now, that time, our centralized facility, which was in a non-flood area, was a big boon to the Srinagar Municipal Corporation and to the state, that we could push all this waste to that Athan waste site, which was a boon for us to use that. And now a fashion is emerging that we should go for a decentralized facilities. Now, if in event of a disaster, what to do if most of the decentralized facilities come under water, or there is any other natural disaster? How to manage it? We should have a centralized waste management site. We should not abandon the landfill sites. Perhaps there is a greed of the real estate and other agencies, that who would like to grab the lands and of these landfill sites. We should maintain a centralized waste management site. And in fact, the huge chunk of land is available in most of the cities. In Srinagar, we have about 1,000 canals for that. And for any future projects, these land mass would be of great help, including waste to energy. And last but not least, I would emphasize on an integrated approach of the waste management policy. Some amount of waste may go into the waste to energy, some may go into composting, and some may go for the biogas production, some may be used for the material recoveries. So integrated methods would be of great help. We should not put our all eggs in one basket. Thank you very much.
Thank you. Thank you so much for sharing your thoughts and viewpoints and sharing your experience about waste to energy and connecting it with the Srinagar Municipal Corporation angle. We have a question from Mr. D.D. Maheshwari. I would request Dr. Oh, he's on mute. That's completely fine. That incineration plant, about 25% of inert material comes out as ash. That also needs to be disposed of in landfill. Disposal of compost is also a big problem. Farmer is not ready to take it. What is the solution for this?
I think as for the byproducts of any operation is concerned, whether it is the waste to energy or it is the composting or for that matter ash material, you will have to maintain a centralized landfill site. Definitely, these byproducts will have to be central landfill site and disposed very safely. And it has to be a scientific landfill site where you will have a proper treatment for leachates. You will have a proper monitoring of the groundwater quality, and from time to time. And it's also important to have a proper order control, because any landfill site or any waste to energy program whereby you are handling the waste, order control is very important, and there are solutions for that. And in fact, it was of great help, especially in the post disasters, once you have a huge decomposing materials all over. And in fact, it looks very good on the pictures, but once you see and move around the areas which are inundated and where the water level has gone down, that it is very stinky, dead animals all over. At that time, order control strategy has to be a part of any solution which is provided under waste management.
Absolutely, and I hope that answers the question. And now I have a question for Dr. Das. Dr. Das, I would request you to turn on your video. The question is from founder of Dan Energy. He's asking the cost of production of products you're mentioning is from source to user point or Reliance cost of production.
That, of course, includes the gate price usually. So it includes feedstock price, operating cost, and also the cost related to the uh, capital. So this is the finished product cost.
Okay, thank you. I hope that answers his question. Moving on, I have a question for Dr. Kasba, that how much growth do you see in the sector where India has a certain potential and what we have achieved and realized so far is hardly 5 to 10% of that. How much growth do you expect in this sector?
Uh, I think I would say what we have seen the last 1 decade, it would be many times higher in the coming 10 years. And in fact, the awareness and inclination and the focus of both federal and the state governments is very huge. So I would say it would be a many-fold increase in the coming 10 years. And I think industry will have to tighten its belts, just make smart technologies available to the users, to the municipalities, to the towns, and to the villages also, whereby panchayats would also be interested in smaller solutions, and but effective solutions, which would be very important as far as ecology and environment is concerned. New challenges are there. I foresee a huge demand for all these technologies and for this sector in the next 10 years. And we should be ready for very liberal investment.
Absolutely. And I would like to push the same question to Dr. Das on his personal capacity, that what do you see? How much do you expect?
I think it is very significant. We have just not begun. We have been dependent so far on importing crude and importing gas and everything importing, you know. But here we are agri-based country. We have a biomass capacity of roughly about 170 million ton, right? We have a huge MSW. We have waste plastic. Now these all are so far neglected. In fact, these are considered waste so far. These are no waste. Waste plastic is a huge source of energy. It can be converted to virgin plastic. It can be converted to oil. Now this biomass people consider is a waste. Look at today, it's an environmental challenge because it is being burnt on the field. But if it is taken out, briquetted, then it becomes a fuel as good as coal. In fact, it's a circulatory fuel. It's a green fuel, right? because it is a carbon neutral feedstock. So I think this arena is just beginning to grow. Fund actually is there, but the technologies need to be really updated. You need to have, you cannot depend on subsidy. Let me tell you very frankly. A technology which depends on subsidy will not sustain. It is not sustainable that way. We need to have technologies which are efficient, which are able to convert carbon more than 80%, more than 70% at least, right? And it needs to produce fuels, energies which are sustainable. You cannot produce, for example, you cannot produce a bio crude which cannot last for 2 days. It has to be a stable liquid. It should be transportable, storable. It has to be brought back to refinery and mixed with the regular crude that we are buying. Then it becomes sustainable. So waste is not waste. If the technology is there, it's up to the technology developers and the technology providers to supply the technologies which are sustainable, efficient, and economic technologies. Then these waste will no longer be waste. They actually would be feedstocks of immense value. That is what we are heading today, and I totally agree with Dr. Kasba that this is the arena which will see multifold increase in investment.
Absolutely, and agree to that. And next question is from Mr. Gurkirat Singh Gill, Director GRV Real Infra, is for Dr. Kasba that waste to energy in municipal solid waste is not cost effective. Should not the government or ULB heavily support the capex and recover through future generation of energy?
Absolutely. I think I did mention it. I said that it is very capital intensive, and I think even Dr. Das mentioned, I won't call it a subsidy. I would call it a initial push till the technology reaches to a point where it is sustainable. And definitely, I agree with the gentleman who asked the question. What's his name?
Mr. Gurkirat Singh Gill.
Mr. Singh, thank you very much for a very, the question is being asked all over. It's a very relevant question. And I think initially capital intensive industries, or for that matter, in the public interest. This time, if we are talking about handling of municipal solid waste, it's 100% government sponsored program, and hardly few NGOs here there have come up, but municipal corporations, municipal committees, councils, they take care of it. I think government is taking a burden, almost over 90% burden of cleaning or the country is with the government. So I think if smart solutions are there, we could, on a very sustainable, in a progressive way, and in phases, hand over it to the private sector, and make use of appropriate technologies which are sustainable, which are feasible, but at the same time, federal government supports it as a mission program. And in fact, I did mention in my initial remarks about the cost sharing also.
So I have a follow-up question for you, which revolves around somewhat on the similar lines. That what, according to you, is is the general sentiment towards setting up waste-to-energy plants? Do they expect enough cooperation from municipal bodies, since setting up of plants involves land acquisition and capital expenditure? It actually involves both of your position of being a former municipal corporation commissioner and at the same time senior advisor at Irade. So this is a question where people want your views on that.
And I think all the waste management programs uh, are very important programs in the states and the country. And the people in the highest level of authority, say chief minister, even our prime minister, talking about single-use plastic. And this shows the importance being given by the government at different levels. And definitely, as I said, once you take it, any project in a mission mode, entire hierarchy in the government would get involved. But the solution have to be smart, solutions have to be appropriate, and solutions have to be sustainable.
I hope this answers. Next is for Dr. Das, that on the technological front, what are the advancements that we are going to witness in this sector from Reliance Industries Limited?
Actually, I just gave you a glimpse of couple of technology arena, but many of them are focused on waste. We don't consider waste as waste. Actually, they are a source of feedstock. They are source of carbon-rich feedstocks. We need to know how to convert these into the products of sustainable nature. So, for example, waste plastic we had given that the troubles of today's technologies need to be addressed. Then only the future technologies are going to sustain. What are the troubles I had said? That the waste plastic, the depolymerization rate is less, temperature requirement is high, product is not stable. It does not last for a couple of days because of oxidation stability problem. So if it must be catalytic product, I would say that most of the future technologies are going to be sustainable if we can use catalyst somewhere or other. You have seen that catalyst is common in all the Reliance technologies. In fact, so far of last 70 years, gasification has been thermal. This is first time we are introducing catalyst in the gasification, which is age-old thermal gasification process. It is not easy. We are not introducing first time catalyst. Catalyst has been tried for last 30 years in gasification, but not much success has been achieved. But this time, this catalyst is actually, we can fluidize it, we can circulate it around, and it does a solid catalytic gasification. So these kind of technologies are not always, developed so easily. It takes time and effort. I believe that future technologies would be catalytic in nature. They would be much more efficient for carbon conversion. They would require, because catalytic, they would require less temperature and therefore more energy efficient. And it would produce products of high quantity and quality. So that when I say that if you are dependent, initial, priming of technology, it's fine. But if you are ever dependent on the technology for subsidy, then you are in trouble. The technology must be efficient and it should sustain on its own. That means it should produce net cash out of it. Then you get a lot of investment, and that is where really efficient technologies do count. Like you see here today, most of the technologies in 2G bioethanol, it produces only 20% ethanol, right? From the same agro biomass, which this 3G will produce about 45%. You talk of most of the thing today, if you talk of agro biomass, most of the people are trying to convert it to CNG or bio CNG or simply biogas. How much conversion you get? Only 13% is biogas. Rest is all manure, and you cannot make a large scale plant because you have a lot of manure. You have to send it back to landfill. I mean, to the land as fertilizer, biofertilizer. I'm not saying they are not required. They are required, but actually that constraint the scale of the technology. You cannot make a very large scale plant. Whereas if you can convert that 80% unconverted, the lignin part of it, if you can convert into again useful products, then you have a very high conversion and you get very good quantity of bioethanol. Actually, green hydrogen is an immense potential, which again can be produced from biomass. You see, and today the whole world is talking of hydrogen. So therefore, there is a very big potential. This arena is just beginning to grow, and in fact, we are agro country. We have a lot of biomass. Everybody needs to consider that this is an opportunity for us.
Absolutely,
Yeah.
absolutely. This is an opportunity and a great sector. Yes, Dr. Kasba.
I think it's a pleasure listening to Dr. Das. I think sometimes you feel what you're thinking inside is spoken by an eminent expert like Dr. Das. It's really pleasing. I would say that we leave always thinking or producing reports or doing brainstorming, drawing out councils like Niti Aayog and all that. Private sector and the industry also should have a think tanks whereby you will have a mix up of experts from the field, from the farmers, from the experts. Even you could technologists from different IITs, so that you have at least once in a year you have a meeting, and you push your ideas together, focus your ideas, and present viable solutions to the government. Because in government people are very busy, everybody is busy. I won't say in industry people are not busy, but unless until proper solutions are provided by the industry, not with one industrial house, but industry as whole. Reports are provided, good information, filtered information, technology lists, technology baskets are provided. Then the decision making should be left to the government. So accordingly, it could be incentivized also. Government, there is no dearth of funds as for urban development is concerned. Solid waste management, we have seen smart city projects. Depending, we have seen very meager. Most of the projects are not even touching the 50% of the expenditure. I think a lot of synergy has to be there between the industry and the government and the institutions of learning and all those who are involved in R&D. Thank you.
There's a follow-up here. So, taking that point, our next question is from. Okay, there's a statement for both of you that you've made a relevant point from thought to action move is required. So, moving to the next question that we have received is what are the policies that you feel should be adopted or implemented or changed from the government which will boost the sector? I'll repeat it. What policies need to be changed, evolved, or adopted to boost this sector?
This question for Dr. Das or for me?
It's an open question.
Would Dr. Das take it? Or
Yeah, okay, let me quickly address it. Actually, in our country, unfortunately, the incentives are not much there. If you compare with Europe and US, their biofuel is a major primary sector now. It's a renewable fuel. Why is it so different? They have all kinds of feedstocks. I'm not saying that those feed we can have it here, like they have a lot of corn and many other food stuff they convert in US. But the primary incentive is that they have a lot of value addition they add in terms of for renewable biofuel. They give lot of incentives at the retail end and to the producers, and so much so it is more than actually the buying cost. Like a gallon, $1.3 a gallon, and on that the incentive is $1.6. That much is the incentive being given in US, and similar in Europe, and it is occurring last 10-15 years. Now what has it done? It has actually created a whole lot of uh, economy around the biofuels, and right from crops to specific treatment. They have now biorefineries. They are converting big refineries which are so far running on crude to biofeedstocks. But in our country we do not have such scheme. Even the feedstocks which are available, they are not organized. Some are being left to the field for burning. You see the scenario, it's completely unorganized. Why is that? Because there is no incentive to do what we want to do. And these are creating all kinds of waste burning problem and pollution problem. We are living with that. But instead of really, monetizing the feedstocks and creating an ecosystem where the whole thing will run efficiently. So we need to learn, in summary, what I'm trying to say is we need to learn, adopt both push and pull. The technology need to be created which will push the economy towards the renewable and biofuel, whereas the pull has to be from the market and from the government policy bodies to adopt some of the things which are being adopted, being run in US and EU, especially towards biofuel, to make it more practical, to make it more economical. So that a lot of funding can come into this arena, because that is how we become sustainable. Unless in today so far the economy is being run in straight line, you produce, you take feedstock, produce product, use product, and throw product to environment. This is not sustainable. This is not going to last for long. In fact, days are coming when circularity is going to be one key feature. Like today, green is the stamp being asked for. Similarly, circular is another stamp which will be partly substantiating green technology. Unless one is circular, unless the technology is circular, it is not going to be sustainable solution. You see, for every raw material that we use, suppose you take out raw material from nature. Now, Mother Nature is supplying that water. Now we are not actually returning the water back into the earth. What would happen? It becomes a waste and it actually goes waste. So you will have water depletion problem. India is already having that water depletion problem. See, so what I'm saying in summary is the technologies have to be sustainable and the policies also need to help that sustainability. And we need to adopt some of the things which has been done in US in terms of policy matters and providing incentives in a way so that initial phase the technologies become become available, become viable. Because initially any new technology you develop, it has its own challenges. It passes through a phase of development where it may not be 100% efficient. So during that phase, this technology needs also some kind of support. So both push and pull are needed. These are, thank you.
Would you like to act, Dr. Kasba, or we move to the final question?
I would say what Dr. Das said should be communicated. I am sure should be communicated to the Ministry of Environment and Forest, Ministry of Urban Development. What's important that in the government of India, or for that matter in the states, decision-making apparatus is there in place, but the people looking after this, they're under highly tremendous pressure as for doing the routine work. In our country, routine work is the order, and thinking and innovating. I think we should have a consortium of Indian industries, especially on municipal solid waste, waste to energy, and other related aspects. Good work or the incentivization of the green energies is being done in the Europe. That's very important. And sooner we learn, it would be better. This country can just take a lead. I assure you that somebody has to bear the cat. Somebody has to put it in the ear and eyes of the government of India that things are like this in a very focused way. If one industrial house talks about it, it may not have that sort of a huge weight, but consortium of industries. And I think you can take a lead in making a small group of the industries who are handling waste energy projects. Let a message go from this, and a policy paper and a basket of technologies and incentivization, which has been done by the European countries especially, and how they are pushing it now in a big way. That should be our agenda in the next 10 years.
Absolutely. And after this wonderful talk, we have one more question, but we have one more request from Mr. Gurkirat Singh Gilji, that a request for IRDA and RIL. Can you prepare model feasibility reports available off the shelf for the entrepreneurs? No such help is now available, and feasibility is just one example where institutions can help. It's a request that we received.
Consortium. I don't think. I think there's a demand. I tell you, there's a huge appetite for all these technologies, all these solutions. But are we ready? Even with the industries, I would say, are you ready for this? I think we have to get ready for it. Dr. Das could take a lead. You could take a lead, and because you people have the space, you people have that level, altitude available, whereby you could coordinate.
Now moving to the last question that we have, and after that we'd request if both the speakers would have anything to conclude. But this is the last question that's again an open question for both the speakers, and it's kind of an interesting question that we have received, which summarizes the entire discussion. That the high capital operations and maintenance cost of waste to energy systems And very importantly, the buzz around solar and wind power has slowed down the waste to energy sector or has set waste to energy to a lackluster, or is it a hype and we are moving towards a great vision for waste to energy?
Okay, you want me to answer?
Absolutely, please.
Actually, we have compared different source of renewable energy, solar, wind, biomass, and for all kinds of products like biocrude, uh, CNG, bio-CNG, ethanol. Uh, in today's uh, solar price of, let's say, 3 rupees per unit, most of the processes involving solar, like solar energy, any chemical you want to make out of solar energy, including hydrogen, they are 5 times costlier than you start with biomass. In summary, what I'm saying is that for solar to be cost competitive with biomass, the cost of solar has to be less than 60 or 70 paisa per unit. Solar has to go a long way. Not only the cost of the solar, the floor area you need and the quantity of solar energy you need is also no less. But that is, these statements are not to undermine the solar. Solar is a great future, I would say. But actually biomass is today's future, and solar could be future for next 10 years. Solar has its own growth. The most important use of solar will be for supplying the energy sector. But wherever you have other applications for biomass, today biomass would be far more cost competitive. So in today's price, if you ask me, there is no comparison. If you, anything you want to produce like CNG, ethanol, methanol, we have shown in my comparison in the presentation I had shown, they would be far more, at least 3 or 4 times cost competitive, cheaper compared to equivalent solar energy. But solar is also growing. Solar energy efficiency is growing. Today it is no longer 20%. It can, I mean, it may be reaching to 40 to 45% solar energy efficiency may be reaching. The cost of photovoltaics are going down. So solar has a great future. But don't, uh, I am not doubting about that. But biomass is a great renewable feedstock, and we must adopt best technologies and apply it for our country's benefit.
That's a very clear statement made by Dr. Das, and we have one request before we move to Dr. Kasba from Shakti Pandeji, former Executive Director ONGC, that he is joining us on stage for the question.
Yeah. And then my question goes to Dr. Asit Das. My question is, recently came across a research paper that the efficiency of gasification can be increased by the application of alumina as a catalyst. What it says, that alumina can convert produced steam into the hydrogen. As a result, the efficiency increases. So have you come across this type of?
Yeah, I partly understood what you are asking. You are saying that there is a research paper who speak about using alumina as a catalyst for gasification.
Yeah, correct.
Actually, yes. Actually, the alumina is the support which is used, but the active catalysts are different. So far in the gasification arena, people have been trying to use catalysts some people have used nickel. These are all active catalysts which are loaded on alumina support. So but alumina per se does not provide any catalytic activity. For gasification catalyst, the catalyst must be basic in nature. That's the first principle. And alumina usually is amphoteric or acidic in nature. So therefore, alumina provides the support, but this on its own does not provide catalytic activity. So that by and large, but so far whatever catalyst people have tried in gasification, it works well when you are able to load on the petcoke or coal. But the problem is the catalyst get lost when the gasification occurs. The catalyst ends up as a fly ash, and you won't be able to recover that catalyst. That has been the challenge for last 25-30 years. So what we have done is we have actually put this active site at the catalyst as a separate solid particle, right? And when the gasification is occurring at low temperature, so 700 degree you are getting full conversion roughly 700 degree, unlike 1400 degree in thermal gasification. Here you do gasification at 700 degree without any oxygen. It's only steam gasification you are doing, but the catalyst is separate particle. So this was not possible so far to utilize a separate particle catalyst which is a solid on its own, and it will catalyze another solid which is the feedstock. The coal, coke or biomass is a solid feedstock. So this solid catalytic reaction, so far it was not possible. Now our study and our patents and our process what we developed, this is the breakthrough we are talking, that we have achieved a solid catalysis. Am I clear?
Yeah. I'm pretty clear now.
Thank you.
Okay, thank you very much.
Thank you, Dr. Pandey. Moving to the last question is from Setu Dubey, Regional Sales Manager for Johnson. Does biomass gasification ultimately release more CO2 in the environment, which could have been avoided by landfilling?
Actually, landfilling is dangerous for biomass for the simple reason that it produces methane. And methane is 10 times more dangerous than CO2 in terms of greenhouse gas. So it is not a solution at all. For biomass is full of energy. It has got very good calorific value, and it is renewable feedstock. And if we don't utilize it, if we send it to landfill, or if we allow it to go into waste into the fields, it will produce methane and it will produce CO2. So this is not a solution to waste the biomass. We must be able to utilize it, and the CO2 that is produced is not counted in, even up to scope 3, it is not considered as CO2. It is not accounted as CO2 footprint. If you use a carbon neutral feed like biomass, the CO2 thus produced, it goes back to atmosphere, but it again in the next cycle of crops, it again comes back as a biomass. So therefore, it does not increase the net CO2, unlike the fossil fuel, which you take out from ground and you produce huge amount of CO2 in one go. So this is the differential. Biomass is a carbon neutral feed. What it means that any CO2 it is produced, it is not considered in scope 1, scope 2 and scope 3 as a CO2 produced. It is not even accounted. So therefore these are called green products. That's why all biofuels like diesel, jet, gasoline, naphtha, anything that you produce from biomass will be called green biofuel. And there is no CO2 penalty on the CO2 which is emitted to atmosphere during this process will not be counted in scope 1, scope 2, scope 3 documents. So therefore, biomass indeed is a green feedstock. We should have no doubt that not utilizing this feedstock and depending on fossil fuel is not at all good, not sustainable. And for our country, it is more important because look, we do not have fossil fuel. We do not have gas, but we are importing, and a huge amount of Indian money is getting into buying those. And we have here agro biomass, which is available in 250 million ton, right? If we can convert into biocrude, it can produce almost like 55 to 70 million ton of very good quality of sustainable biofuel we can produce. So I think we must act on it. We are already late, but technologies are emerging, and I am very sure that in next 5 to 10 years, our dependency on biomass will increase and dependency on fossil fuel will reduce. This I'm clearly seeing the future.
Thank you, Dr. Das, and here we end the questions. I would ask Dr. Kasba if would like to add so that we can finish the session.
I think it is really a pleasure of listening to Dr. Das. And what's important that we would say it's not wind versus solar, solar versus all these technologies are green technologies. And we have seen that efficiency of photovoltaic cells is increasing. The cost of production is going down. So accordingly, that time always gives the fine tuning to the technologies because it helps. And as we were 40 years back, as for solar is concerned, we are better placed now. But there are some limitations, as Dr. Das rightly mentioned. Space constraint is very important. Then grid connectivity is another important thing. And but area like Ladakh, we are exploiting in a big way where we don't have issues with regard to the space. There's a huge land mass available and 300 days of sunshine. As for other issues are concerned, I would say that what about the bioplastic? Dr. Das should make us wise on this issue. Bioplastic is something which is going to be a game changer because single-use plastic has created huge problems in our overall city management, drainage, sewerage, and all landfill sites or any place you see anywhere where dumping of municipal waste takes place. It is the site of these plastics, and somehow it has not gone down. Very sorry to say. So how soon we can have bioplastics? Is there some incentive on its production, some sort of incentive which the government should give, or is it there, or is it not there? Dr. Das could help us because I have seen that Reliance producing plastics in Anand, and I have visited using Reliance pellets and all that, producing normal synthetic. But the same process is for bioplastics. And where we are as far bioplastics is concerned, I think Dr. Das is a great opportunity to listen to you.
Okay. Yeah, thank you, Dr. Goswa. Actually, plastic. There are two types of plastic, which are used for bottle like PET bottles, etc. Those are one kind of plastic. The other kind of plastic is polyethylene, polypropylene. Now, between these two, the difference is one is having oxygen, another is not having oxygen. Right? The plastics which are carrying oxygen like PET, etc., they are best recyclable. Actually, we are recycling it. Almost 90% of PET bottles are getting recycled today. Reliance itself has got established factories for that. So those are best suitable for mechanical recycling, and we are already partly doing it. The second part, which is the polyethylene, polypropylene, LDP, HDP, polystyrene, etc., those are the ones, and multi-layer plastic, MLP, which goes into packaging and all those, and single-use plastics. These are the real culprit today. And today, actually, although these technologies are here and they are in small scale, the economy of the scale is not there. Multiple plants are not there. This is what Reliance has taken this vow that we are going to change this landscape. We will not allow the plastic to get wasted. You see, we have 10 million ton of plastic. The spent plastic is roughly about 7 to 8 million ton today. And much part of it we see here and there in loitering around. And once this technology is demonstrated that I had shown you, the catalytic pyrolysis, this has potential to change the landscape for the plastic. Why? Because this is economic even at today's cheap crude price. Still this process is economic. It will be producing cost competitive crude oil and bring it back to refinery. Why I will not do it if the process is profitable? And it will create whole lot of employment in the rural sector as well. Not only to create the waste plastic supply chain, collect it from landfill, process it in these plants in rural sectors as well as near landfill. We plan to put up all these plastic conversion plants and bring the oil back. We'll have buyback arrangement. So it would be a win-win scenario, and I'm almost sure once the technology, we are in the demonstration stage, another 4 to 5 months, we hopefully cross that, and then we will be, bringing up 20 ton to 50 ton per day plants in different parts of the country and get the plastic back, convert it into oil, and bring the oil back to refinery and process it. This is what actually will make the plastic economy circular. Otherwise, plastic economy is not going to be circular, and anything not circular economy is not going to sustain. Every nature, all the cycle, you look at nitrogen cycle, look at carbon cycle, every cycle that nature has produced, it has made it circular, and by circularity it has ensured that it sustains. Millions of years it has sustained. But human being has not followed the circular economy principle, right? Our honorable chairman has said that by 2035, Reliance has taken this promise that we'll bring carbon neutrality, we'll make carbon zero in Reliance by 2035. Our honorable chairman has declared that in last AGM. And this is just the beginning part of it. We have already started fetching how shall we make such a huge business in all around. How do you make it net zero 2035? When European countries are talking 2050, 2060, and those kind of timeline. In fact, we want to do it much earlier than that. Now, same way, we have also taken a vow that being a major plastic producer in the country and in the world, we are not going to allow this plastic to go into waste. We are developing this technology, and we will be able to convert this technology into oil and bring it back. Now, coming back to this bioplastic, which Dr. Kasba has asked, actually, bioplastic is some way the bio part gets biodegraded very easily, right? But it also has some part of plastic, and that ends up in the microplastic. So when you add biosubstance into plastic process, there are some microplastics which get produced, right? So it helps in rapid degradation of the bioplastic, but the microplastic plastic is not degraded again, it ends up in the sea. So this to me is a solution which is half solution. It may create some other problems as well. This is being looked into, but the other part is of course the cost. So to me, the plastic world is looking for an efficient catalytic process which can convert the waste, MLP, single layer, all kinds of plastic that you talk about, and which is ending up in the landfill. We have to get it back from landfill and convert it into fuel and chemicals, and in fact plastic again, not even fuel, we need to again convert into plastic. Then you have established circularity, then only it will remain viable, and it will sustain only then. Otherwise, plastic business in this manner, if we run, it will not sustain. It has to be sustainable. For that, we have to have such kind of process that brings the waste plastic back into the virgin plastic circuit. But for PET kind of plastic, we don't have. We have already solutions for that. We are, in fact, India is one of the major recycler for PET kind of plastic. It's a very big initiative.
Thank you.
So the real problem is with the single-use plastic.
Thank you much. We'll stay in touch.
Thank you, Dr. Das.
Mr. Akshay and Dr.
Thank
Das
you.
will stay in touch.
Absolutely. Thank you, Dr. Das, and thank you, Dr. Kasba. Due to time constraint, we have to end the session. It was very informative, very knowledgeable, I'm sure, for the audience who have joined us for the session. Thank you so much for joining us, for delivering the presentation and sharing your thoughts and viewpoints on the subject. We are glad to have you on board. We look forward for your future participation in our future conferences. Thank you so much.
Thank you, Akshay.
Thank you.
It's a great pleasure
Thank you.
to join this.
Thank you.
Thank you, Dr. Kasba.
Thank you, Doctor.
Thank you.